Okay, so for this project, we started out by finding the area of polygons that were on the outside of circles. So starting here with the square, we have the area of this triangle, which is 1/2 of base time height. The base is just 1 because it says it here that the radius is 1. And then the tangent of theta is the height. So we have 1/2 of the tangent of 360 degrees over 8 times 1, which is the base. So this reduces to 4 times the tangent of 180 degrees over 4. So the 4 that's multiplied by the tangent and that's in the denominator is going to end up being the number of sides that the polygon has. So the area of a pentagon is the 5 tangent times 180 degrees over 5. The hexagon reduces to 6 tangent of 180 degrees over 6. So the formula to find the area of an insided polygon would be n times the tangent of 180 degrees over n. And that's assuming that the radius is 1. So writing that as a limit, as n, which is the number of sides of the polygon, increases, the tangent times the tangent of 180 degrees over n. So whatever the limit is getting closer to is what the area of the circle would be approaching. Now using a polygon that's inside of a circle, we have the area of the square is 4 times. Actually, I need to rewrite that. That one's wrong. So we have the pentagon is 10 times half of the sine times the cosine. So when this reduces, it reduces to 5, which is the number of sides of the polygon, times the sine of theta, which is 180 degrees over 5, which is also the number of sides of the polygon, and the same for cosine. So as you could see, the hexagon, it would be 6 times the sine of theta, which is 180 degrees over n, which is the number of sides of the polygon. So again, here's the equation written out. It'd be n times sine of cosine, which is 180 degrees over n. So as the area of the polygon will start to fit better and better into the circle, and it'll get closer to the area of that circle. So this limit would be written as n approaches infinity, n times the sine times the cosine. So these two were graphed out here. In the red is limit 1, and in blue is limit b, which is this one here, the sine and the cosine. So both of them approach 3.14 as n approaches infinity. So they both approach the same limit, however, from different sides. So as the number of sides increases, there were much more numbers after 3.14, but I could tell that they were all approaching 3.14. So the kind of conclusion is that obviously this is the how pi came about, and so I know that the area of a circle is pi times radius squared. So I actually don't have it written down here, but I do have pi times radius is the area, which is kind of the conclusion I got from the formula. I know I'm missing r squared, so I know that I'm missing a little bit there, but I can see that the project was kind of leading us towards seeing where the area of a circle came from.